In this video, I'll show you how to solve the ALEKS problem called identifying and drawing hemiacetals and acetals. This particular problem is going to give you a few different molecules. I'm only showing one, and it wants you to determine whether the molecule is a hemiacetal, an acetal, or none of the above. Another option of this molecule is that it would give you instructions or like criteria for drawing a molecule that was either a hemiacetal or an acetal. For example, it might tell you how many carbon atoms the molecule needed to have. Say that it needs to be an acetal, something along those lines. So what I'm going to do is just focus on the difference between these two functional groups, the acetal versus the hemiacetal. I'm going to start by talking about what they have in common. Acetals and hemiacetals each have two oxygen atoms that are separated by one carbon atom. That's something they have in common. So if you're looking for acetals or hemiacetals, the first thing that you should be doing is focusing your eyes on the oxygen atoms in the molecule, because that is where you're going to find the acetal or the hemiacetal. To be clear, these are going to be oxygens that are single bonded to carbons, no double bonds allowed. So this molecule has got a total of 4 oxygen atoms. It's possible that only 2 of the 4 are going to belong to either an acetal or hemiacetal group. And what we're looking for specifically are 2 oxygen atoms that are separated by exactly 1 carbon atom. Only 1 carbon. Can't be more than 1. So if we look right here, that is definitely what we're looking for. We've got 2 oxygen atoms that are separated by 1 carbon. This is not an example of an acetal or hemiacetal. These 2 oxygen atoms are separated by 2 carbons, which makes them just nothing special. So this is the acetal or hemiacetal functional group. This molecule has it. The difference between the hemi and the regular acetal is that the hemiacetal, one of the oxygen atoms is going to have a hydrogen attached directly to it, and that is not going to be the case with the acetal. So if we look at this molecule right here, both of our oxygen atoms, neither one of them have a hydrogen attached, and that makes this molecule the acetal. Now, just to give you an example of what it could look like if it was a hemiacetal, I'm just going to erase part of the molecule. If it looked like that, then it would be a hemiacetal, because one of the oxygens would have a hydrogen attached directly to it.